working with exponential functions. I'd like to take a look at three examples here to get the idea of exponential functions, and we'll start to look at some more complex functions that are exponential in nature, as well as looking at the graphs of a few exponential functions. Let's start here with example 1. In example 1, we're asked to evaluate this expression. We have in parentheses -1/2. We're going to take that to the third power, and then we're going to take that result and raise it to the -2 power. If we're careful with parentheses, we can do all of this in one step. And if we use the features of the calculator that allow us to view our answers in fraction form, we should be able to get back a fractional answer, which is what we want since we start with a fractional answer. We don't want to answer a question like this with a decimal. Alright, so let's start. And what I'm going to do is pretty much just enter it the way that I see it here. I'm going to start by opening a parenthesis for the first bracket that you see. Then I'm going to open another parenthesis for the actual first parenthesis we see. Then I'm going to type in -1 divided by 2. Remember, a fraction like -1/2, where the negative is out front, can also be written as a fraction with a negative in the top or in the bottom. So what I'm doing here is choosing to write it as -1 divided by 2. I'm going to close that first parenthesis. I'm going to raise the expression to the third power. That's going to raise the -1/2 to the third power. Then I'm going to close the bracket. The calculator only has parentheses, so we have to use them for brackets, parentheses, and the curly braces that you see from time to time. Now we want to raise to the -2 power. If we were being cautious, we would put the -2 power in parentheses, although the calculator will allow us to do it without. I'm going to be cautious. And just to help remind myself that sometimes there are things I absolutely have to put in parentheses when I'm doing exponents. I'm going to type it like this. So let's press enter and see what we get. And this one actually comes back as an integer, 64. Now that you know what the answer is, you could go through and try to work this out using the rules on pencil and paper and see if you can come up with exactly the same response. This is a way to potentially reinforce all those exponential rules that you've learned in earlier algebra courses and are being repeated here in this algebra course. Alright, example 2, we're given this function here. N of t is equal to 35.5 in the numerator divided by 1 plus 6.89 e to the -0.8674t in the denominator. And we're asked to find n of 4. All right, this is something called a logistic function, and you'll learn a little bit more about logistic functions later. But right now we just want to see if we can't substitute and get the correct answer here. And the real trick with a function like this is to use parentheses properly to force the order of operations to do what we want them to do. All right, so let's start here. The numerator is just a number, 35.5, so we can just type that in, 35.5. And then we're going to divide by the denominator here. Well, we can see that the denominator has other operations going on inside of it. So we want those to happen before the division represented by the fraction bar actually occurs. So I'm going to open up a parenthesis here, and then I can start typing 1 plus 6 point 8 9, and that's times e to a power. And you'll notice on your calculator e shows up in two different places. It shows up just above the divide key all by itself with e. We don't use this version of e very often. It's a nice place if you want to see the decimal value of e. Just press second and the divide key, since e is in the same color as your second key, and then press enter, and it'll show you the decimal equivalent out to I think it's 7 or 8 decimal places. More often though, we're going to be taking e and raising it to a power. That's usually what happens with this number. So if you look on the left-hand side of your calculator above the ln key, which we'll talk about in another video, you'll see e to the x. And all this really is just a shortcut key. If we press the second key and the ln key, what it does is it gives us e and it raises it to a power and it opens up parentheses for us to put whatever we need to put the power in. Usually when we do something like this, it's in a situation where we do need the parentheses for the power. You can use the e on the right hand side of the calculator and then raise it to a power and open up parentheses. But the left hand side is just a little bit shorter. It saves some keystrokes. Alright, so here I have e, this base of the natural logarithm, which you'll learn about more later. And we need to raise that to negative 0.8674 times t. In this case, t is 4. We finally get to this 4 here, or we're considering n of 4. So I'm going to type in negative 0.8. Oops. I got one too many 8's here, so I'm going to cursor back one and press the delete key to get rid of that second 8. So we have 0.8 and then we want 674. Now you don't need to put the 0 in front of the decimal. You also could have just typed negative 0.8674. We want to multiply this constant by 4, so we hit times and we hit 4. Then when we close the first parenthesis, we're closing the parenthesis on the power of e. Then there's a second parenthesis to close, which is the original parenthesis that we opened up for the whole denominator. The calculator is pretty forgiving if you get parentheses wrong. It may have some problems if you use too many closing parentheses, but if you have too few, the TI-83 and 84 calculators are pretty forgiving about that. Others not so much, but these are pretty nice that way. All right, we're going to press enter, and there is our answer, 29.23056627. I'm sure that decimal keeps going, but this is what the calculator is showing us. In most problems, we would be told to round this to a certain number of decimal places, or we might be given some hint from the problem statement as to how many decimal places to round to. All right. But again, the big lesson here is be very careful with parentheses. Make sure that what you type in, that the calculator, when it does order of operations, does what is intended. Third example that I have for you here is to graph three equations. And these are all exponential equations. And what I'm going to do is I'm going to graph all three of them at one time. So to graph things, we need to go to that y equals menu. Then we need to type these things in. So in the first one, y1 is going to be equal to 2 to the x power. And I'll press enter. And the next one I'll have 4 to the x power. And by the way, if I haven't said this in other videos, if your problem has a different variable than x, like if these were y is equal to 2 to the t and y is equal to 4 to the t, you'd still use the variable x on the calculator. The calculator is always going to want to graph things in terms of y and x. So you may sometimes have to convert the variables in a problem in your textbook to y and x for work on the calculator. All right, then we have 1/2 to the x. I'm going to type it exactly as I see it here. I'm going to open up a parenthesis, type 1 divided by 2, close the parenthesis, and raise that to the x power. All right, now there's all three of my equations that I want to graph. And before we go and graph this, I just want to remind you that when the calculator graphs, it's going to graph these things in order. y1 first, then y2, then y3. So we'll be able to see these things as they're coming up, and we will know which one is which. I'm going to graph these in a standard window. So I'm going to press the zoom key, and I'm going to choose option number 6, standard. That'll set the window to -10 to +10 on both the x and y axes. All right, now y is equal to 2 to the x. When x is negative in this case, it's a really small number, so we don't really see the graph until the number gets larger, as it is starting to here. And we can see it picking up, and it starts to grow very quickly, exponentially, if you will. You should also notice on this graph that y is equal to 2 to the x passed through the point 0, 1. Now, we're waiting for 4 to the x to come up here. Again, when x is negative, it's pretty small, so we don't see it at first. But as x starts to get larger, we do start to see it. And it grows even quicker once we get to the positive x's. It looks even steeper, if you will, because we're growing even faster exponentially in this case. This graph also passes through the point 0 and 1. All right. Now the last one we're going to get here is 1/2 to the x, and you'll see this looks a lot different than the other two. It starts very steep on the left-hand side and then slowly tapers off and comes down and gets close to 0 on the right-hand side. This also passes through the point 0 and 1. And if you think about it, if you apply some rules of exponents here, 1/2 to the x power is the same thing as 1 to the x power divided by 2 to the x power. Now 1 to any power, x, is always 1. You can multiply 1 by itself as many times as you want and you always get 1. So that's like 1 divided by 2 to the x, and we can write that as 2 to the negative x. And that's why we're getting this different action going on here, is we're not considering x, we're considering the opposite of x for the exponent. And that essentially mirrors the graph. If you were to look at the points for 2 to the x and 1/2 to the x, you'd find out that those two graphs are mirror images of each other across the y-axis. All right, these are all exponential functions. And just a couple of other things to point out and reinforce about exponential functions. You'll notice that the graphs never cross the x-axis. That is, the value of these functions is always greater than 0. The range, if you will, of the functions is always greater than 0. The domain of the functions is all real numbers. I can pick any value of x, negative, positive, small, large, whatever I choose, and I will get a value back. The graphs are smooth curves, they're continuous and unbroken. And when I'm dealing with the base being greater than 1 is in the first two, 2 and 4. I see that the graph grows slowly from the right and then picks up speed and starts to grow very quickly as it moves from left to right. When the base is between 0 and 1, we see that the graph descends very quickly at first, moving from left to right, and then starts to fall off much more slowly. The first two we'll later call exponential growth functions, and the third one we will later call an exponential decay function.